So while that's going, let's have a look at what else we need to do. We're going to need to make a few small changes to our code. So reminding ourselves of the code, we have this keyword ranking program, and I was fiddling around with it a little bit in the last chapter to demonstrate the sorting, but I've returned it back now to the state where we sort by key, take the top 10 results, and then print them out to the console. And that's working locally absolutely fine. But we have a couple of problems, and the first one's quite simple. Line 24, where we're calling this set master, we're basically configuring Hadoop here to run in local mode, and the asterisk is saying run this as a local multi-threaded program using as many threads as there are available cores on the underlying hardware. So that's been great so far. We've been getting a lovely multi-threaded local application, but that would be a disaster if we leave this in place when we deploy it to a cluster, because this would make it run just on the driver, and our executor nodes are going to be sat there doing nothing. So there's nothing complicated to do really, other than just remove the .setmaster local when we're deploying to a cluster. Now the other problem is that the text file here, which I've been reading in from a local resources file, well, that's not going to be available on our cluster. Okay, we're just testing, we're just developing here. This is actually a very small manageable file for now. So I could, I guess, copy that file across to the cluster and have it as a local file just like we've been doing in development. But actually, it turns out to be a surprisingly painful thing to do that, because this text file operation really doesn't work very well with files that you've stored inside a jar file. Now that would be how I would usually work with the text, with any kind of resource or text file or graphic image or whatever inside a jar file. I would put it in this resources directory, and then it becomes part of the jar file, and then I can read it in as a resource. Now I've never found out a way of doing that using this text file method, basically because the text file method just takes in a string, which is a path. Now the reason for this, I think, is just that the assumption of the Spark design is that this is going to be a file. If it's not a local file on the file system, it will either be a Hadoop file system file or something like an Amazon S3 file. So what I would rather do, rather than trying to hack this, is I think we should cut to the chase really and make sure our input file is stored on S3. And we do that by simply using an S3 URL. It's a bit strange. It's actually S3N : //. And the S3N, I think, is just a new generation of S3 URLs. This style of URL has more features than the original S3 : version. Now, if you're following along with me, what I will need you to do is to create a bucket for yourself in Amazon S3 called anything you like. I'm going to call mine VPP Spark Demos. You can't call yours that, because this has to be a globally unique name that has never been used before in Amazon S3 across the whole of the world. So just to show you, if I go to my AWS console, and while I've been talking, yeah, these are still bootstrapping, so still plenty of time. I can follow the link here in a new tab to S3 console. They've improved this console dramatically since I last recorded a course, so it's almost usable now, this. So I've just drilled into my VP Spark Demos bucket, and off camera, I won't bore you with this, I've uploaded the input.txt file to here. This al.txt file, by the way, is just a multi-gigabyte file that I carry around with me on a USB stick just for stress testing and doing basic benchmarking. That file's kind of big enough to give me long-running jobs on my clusters, you know, without them just immediately finishing like probably this file is going to do. You don't need that file, but I might use it in the chapter on performance. Anyway, we've got the input.txt file in place. And in the code, we can refer to it just like that. So this is getting a lot more realistic now. This input.txt file could be a multi-terabyte file on S3. And of course, Amazon will be storing that across multiple disks. We don't care about that. It will feel like a single file. It will not be read into a single virtual machine. When we read this in, actually it's going to be read in by our cluster. So I hope that's been clear so far. And I think that's the only changes that we need to make to our code. So we're going to need to distribute this to our cluster, and to do so we're going to build this as a jar file. So to do that, we'll run the pom.xml. Oh, by the way, before I do that, inside the pom.xml, you'll just need to check on, it looks like line 55. Line 55 has the name of the main class that we're running. So check that carefully. You might have a different package and a different main class. If that's in place, then we'll run the POM, and the goal we're looking for is the package goal, which is going to build that as a jar file, learning Spark. And of course, if we were doing this in real life, we would have this as part of some kind of deployment system, probably integrated into Jenkins or something similar. But we're taking baby steps, so I'm suggesting we're just going to manually upload that jar file. So here I am in my project's target directory. There's the jar file right there, and we'll get that uploaded. Actually, before I continue, I should mention that this jar file it's 11.8 megabytes. I've opened it up here in a zip utility, and actually the size of it comes purely from the fact that I have packaged some practical files for later on in the course into here. Including that input.txt file, even though we're not going to be reading that. So I didn't really need those, and actually the real size of the jar file would be a lot smaller. Now what I really want to point out is this jar file does not contain the Spark distribution. It only contains our code. And that's absolutely fine, because the Amazon EMR has got all of the Spark code installed locally. So we don't need to deploy Spark. It's already there on our cluster. Okay, so I'll just click next, and that should, in fact, I can just go straight to upload, and that'll take just a few seconds to upload the file to that bucket. So the idea of putting it in this S3 bucket is I'll be able to easily download it to our cluster. That is, at least when the cluster's finally started. So yeah, while I've been talking, good timing, the cluster is now up and running. It's quite easy to work with these clusters. What we've got here is a master public DNS, which is going to point to the IP address of the master node in our cluster. So on my regular terminal now, I can use SSH as normal using my key pair file to log on to this instance. The one thing you need to know, again, I'm assuming you know how to do this. We covered this on the original AWS course. The one thing you need to know is that the username is Hadoop and not the usual EC2-user. And that's going to be Hadoop at, well, that didn't work because I thought I had the DNS name on the clipboard. So I'll go back to here and I'll try to copy that again. Okay, that's better this time. Now, the usual deal with AWS, I'm guessing by default the firewall is not open on the SSH port. That certainly looks like it's hanging. So back to the console, and you'll find down here on the page for the cluster, there's security groups for master and security groups for core and task. I need to follow the link to security groups for master, and then I have to select master again here. As always, the interface may have changed for you by the time you do this, but hopefully it's relatively similar. Click on the Outbound tab, and we're going to edit the firewall rules. Don't change any of these existing entries. You'll notice it's put in a lot of entries for port 8443 for a variety of IP addresses you probably don't recognize. These IP addresses are actually other executor nodes that I've been working with earlier. It just happens to have put entries in for them. Anyway, I need to add in a rule for port 22, and I'm going to make it just my IP address. We also need to add in a rule for port, and this is an odd one, 18080. And again, I'll just open that for my IP, and we'll find out what that's all about a little bit later on. Click on Save. Now I can go back to the console and I'll try that SSH again. Oh, by the way, I always forget this. You might need to do, I can never remember the exact settings, but you can certainly get away with doing a chmod of group and others minus RWX on that file. And that will remove read, write and execute privileges for everybody other than yourself. I think that's satisfactory. I should now be able to run the SSH, confirm that I want to add it to my keychain, and there you are. You are now logged in to your EMR master instance.